Let's go ahead and take a look at the next one. Let's take a look at light. And light, we're going to need a light in our scene. Let's go ahead and create one of those. Delete that U deflector. Create a spot here, and we'll modify the spot parameters and give them kind of a narrow field to be dealing with. Let's take a look. Okay, so the light condition, we're going to need a light to deal with, so we're going to have to pick a light. Let's do that. And then we're going to have a threshold that we want to deal with. So it says, okay, when this particle, or this position, it doesn't have to be a particle, but just a position value. In this case, we'll actually use the particle, his position. When his position is in this light and receiving at least this much light, then we're going to output a true. He also has additional outputs here. He can tell you exactly how much intensity of light he's receiving, what color the light is, and what direction the light's coming from. There's also a normal input that you can use to specify, I want to detect if light is coming from a certain direction. Check the help file on that one for sure. But let's go ahead and see what happens when we move our particle through here. You can see that once he enters the light field, let's actually select that light and make his cone visible. So once the particle gets into the light, he's going to start borning particles, borning the green. Let's go ahead and increase this threshold. We want to make sure that there's a lot of light when the particle hits. And let's change the spotlight parameters. Let's decrease his hotspot beam and increase the fall-off field. And let's crank this up quite high. So the threshold has to be really strong in order to born particles. You can see as he comes closer and closer, finally he reaches the point where this particle's position is receiving at least 0.93 value from the light intensity. And then once he's outside of that range, no longer is receiving it, then he's no longer going to be outputting a true. Let's kind of skip ahead. Let's take a quick look at a new function in TP3 called debug mode. Debug mode allows us to receive information from inside the processing and see what those values exactly are. We're going to use that in this case. We're going to go ahead and now it's important to remember that in order to actually see debug information, it has to be used. It has to be part of the processing. Position born, we can just fake this and use the let's use the mass. We'll take the mass from the intensity, which doesn't make a whole lot of sense right now, but what we can do then is, as we cruise through time here, you see this t equals such and such and dt equals 160. What this means is t equals, this is time in ticks. And remember, there's 4,800 ticks per second, so we're approaching 4,800 because our time configuration is set to NTSC. As soon as we reach 30, you can see we passed. Let's go back one. Yeah, so t equals 4,800. dt is the delta time, so change in time is 160 ticks. But what we want to look for is intensity. Now, in order to actually see this information in the debug, we're going to right-click the intensity and say write to debug log. With my color scheme, we've got this set up in red right now, so as we move forward, and actually you can see that particle, first he starts off with light intensity 0, meaning he's not receiving any light. Then he moves into that light field, and you can see those light values start to increase as he moves closer toward the center. Then you could say, okay, well, here he comes. He's going to get close to this this threshold we've got, 0.93. There it is, and there it goes. So now, boom, this guy gets born, and he's spitting out a huge iteration and telling you, okay, well, yep, my light's been born here, and we run pistol shot per call, so we're seeing quite a few values listed. But 0.93, we're all above that, so we're creating particles. Again, 0.98, we're coming up right on the center there. And then, of course, it starts to decrease again on the way down. And until finally he's outside of the cone and receiving intensity 0. So that's just a quick intro to debug. We'll take a little bit more look at that later. And in order to get rid of this debug information, you can either right click there and say write to debug mode, which will uncheck it. Oops. And the other method you can use is you can right click out here in the blank field and say clear write to debug, and that will take out all of them through every rule tree that you have. Okay, so this is light. There's some other interesting things you can do with light. Let's go ahead and take a look at this. What you can do is you can output the actual color, and then you could say take that color and feed it into a particle shape. Let's get the particle shapes in here. Standard shape. You see our debug mode is still on. Let's go ahead and close that. Uncheck him there. We've got this vertex color input. It's also available on the geom instance. We're going to take a look at particle shape parameters in the next video shortly. But one thing you can do is you could, there's the vertex color, is you can take this color of the light, whatever color he's receiving. Let's say you had like a projector map with a big rainbow color or something. You could take that color and feed it into the vertex color of the standard shape or the geom instance. And then if you have a, let's get this up here. If you have a vertex color map applied as the material, then what will happen is, and we'll disable this one, we don't want it right now, but what will happen is the particle, as he enters the light, the color from the light is going to change the particle's shape, his material color. So that's a pretty useful special effect. It's also very useful when setting data channels. We haven't looked at data channels yet, but basically for every particle group up here, you've got this whole data channel section where you can define extra values to store. One of them is color. And what you can do is you can take whatever light value, light color is coming out of here, and on the standard parameter here, standard operators, we've got a data channel. We want to have the data channel be affecting that particle group, and we want to input a color. And so what happens this way is, and the data channel number is 0, the red particle's data channel 0 is color, so that's where this 0 matches up. So the light color, as that particle enters and moves through that color field, or if the light had a projector on it, then that color would get assigned to the particle's data channel. And that can be used in Afterburn and Pyrocluster and Final Flares and quite a few other areas. Okay, so we're getting a little bit ahead of ourselves. Let's jump back into the conditions and see if we've missed any. I think that's about it. Oh, there is one more, which is the in group.